everybody. I wanted to discuss some of the problems from problem set 2 and to show you a couple of code fragments from various people's solutions that I thought were interesting and worthy of discussion. These are the ones that we're going to be discussing in particular: 1BC, 4B, 6BC, and 7. Even if you've already solved some of these, I hope I'm going to say something new and interesting about each one, so I would recommend that you maybe watch this video. I'll be doing the problems inside an editor. I know we used Eclipse last year in Intro Java, but I'm going to be using a different one this year called IntelliJ, which is way better, actually. So if you want to go ahead and download IntelliJ, the Community Edition is free. It's easy to install. You could do that. And then you could follow along with some of the things that I'm going to do here. So problem 1 was about interpreting these nested if statements. So what I've done is I've pasted the code from problem 1 inside a method called problem 1 where I can give it 3 inputs for the values of a, b, and c. And so now the person who asked me about this was asking specifically about 1b and 1c. So in question 1b, the values of a, b, and c are 1, 3, and 2. Already this is going to look different to you than Eclipse. You might be wondering, what is this a:, b:, c:? I didn't type this. This is actually inserted by the editor to show me what variables those values are getting assigned to. So watch as I type. I type 1, and it's inserted the a:. I type 2, it's inserted the b:. I type 3, it's inserted the c:. So that's just telling me that 1 is going to get assigned to a here. So sometimes when you're using somebody else's methods and they've named their variables intelligently, that's great to remind you what order the inputs go. All right, so in IntelliJ, you can run the program up here, or you could also run it here. So I'm going to click on this one to run it. And you'll see what it outputs. Here it's just outputted AK. Let me show you a different thing that you might not know about. This is called running the debugger. So if I click here in the margin on line 7, that's added a breakpoint. And what that means is if I run in debug mode instead of run mode, execution will pause on that line, and I can step through one step at a time to see what's happening. So let me show you how that looks. I click, and instead of saying run, I can say debug. So now it's running, and now you've noticed it's paused on this line. Let's look and see what it shows us. So here on the right-hand side, it's showing me what are the values of a, b, and c as the code is running. I can click this button here to step one line at a time. So I'm going to step one line down. And now we're on this line, and it's showing me what's the current value of b and c. So we're saying, is b less than c? Here, b is 3 and c is 2, so the answer is no. So you can see I'll click the next button, and it's going to jump straight down here to line 16 because the if statement wasn't true. So it's going to skip that entire block inside the if statement. All right, so now, because it wasn't true, we've gone to the else statement. And now we're going to have another test, if b is less than a. So here b is 3, a is 1, so b is not less than a either. So when I click next, it's going to skip that entire block and jump to line 26, which is the else statement. Bang. And then we'll print k, and then we'll be done. So if I go and look in the console, you see it's printed a and it's printed k. It printed a up here before we even started looking at the if statements, and then it printed k. All right, so I can stop it here, and let's look at the next one. Okay, so 1c, a is 2, b is 1, c is 3, and I've made those changes up there. So I'm going to go ahead and run it in debug mode again. And I'd recommend you go ahead and try this yourself, because it's nice to have the experience of doing it yourself. So here we see the current values. We'll print a no matter what, so I'll go down one. Now it is true that b is less than c, so we're going to go inside the if statement, because that was true. So now it's going to print b. And now, is it true that a is not equal to c? Well, yes, it is true, because a is not equal to c here. So we'll enter this if statement. We display c. And when I go to the next line, I'll be here on the else. Because the if was true, it doesn't run the else block. So it should jump down here to line 15, which it does. And now when I run e, now we're done with this entire if statement. So even though it is true that b is less than a, we don't actually do anything else in this program, because we only even look at this if statement if we're in the else condition. And we only go to the else condition if this initial statement was not true. If the if statement is true, you do the block, and when you get to the end, that's over. You don't look at the else unless it weren't true. All right, so let's press next. And now it's jumped us to the very end because we didn't do this else statement and we didn't do this else statement. And that's the end. So we can go back to the console and we see that we've displayed A, B, C, E, which is the answer to that exercise. All right, so for problem 2, we have this for loop where I goes from 0 up to 10, not including 10. And the last part of this exercise instructed you to modify this loop so that it will display the values from 3 up to 21. But I said, don't change this line. So a lot of people ignored that instruction. They said, okay, let's start from 3 and let's go until I equals 21, and we'll go up by 2 every time. And if I run this code, you'll see that that actually works just fine. So that's displayed what I asked you to display. But that's not what I wanted you to do, because it's important to know how you can use the loop counter as the input to a function that will display other stuff. So we're going to keep I going from 0 to 9, but instead of displaying I, we're going to display some mathematical statement including I that's going to turn I into this sequence of numbers. So I guess I start at 3 and I want to increase by 2 every time. So that's sort of like a linear function. It's like if I had f of x equals 3 plus 2x. When x is 0, I get 3. When x is 1, I get 5. When x is 2, I get 7. So you can sort of imagine that this is like the input to a linear function. That this is the output that I want from my linear function. And my input is the loop counter. So 0, 1, 2, 3, 4, 5, and so on. And I've called it, well, we'll call it x. Down here, the loop counter is called I, but I'm thinking about it like the input. So the question is, what function maps from 0, 1, 2, 3, 4, 5 up to these? And the answer is that linear function. So all I need to do in here is say 3 plus 2 times I. And now if I run the code again, you'll see that it outputs the same thing that it's supposed to. Don't show me this again, please. It'll output what it's supposed to here. But I didn't change the values of my loop counter. I just did something with the values. That idea is going to come back in later exercises. So this one we'll look at inside Word instead of Eclipse. So here I've got an if statement. So if x is greater than 0, I do this stuff. Otherwise, I do this stuff. So one thing I'm noticing is that no matter what x is, I do these 2 lines of code. So it's silly to say, if something is true, do method 1. Otherwise, do method 1. Because really, I just want to say, no matter what, do method 1. So anything that's in all of the branches of your if statement shouldn't really be in an if statement at all. Because the point of an if statement is you're testing to see whether or not you want to behave differently. So this is the only line of code that's different. So if x is greater than 0, I want to do this, otherwise I want to do that. But these 2 lines of code happen no matter what, so they shouldn't go in the if statement. So this now is a correct solution. These 2 lines of code to happen no matter what. And now the only line of code that will be different is the line of code that goes inside the if and the else. This kind of idea, eliminating duplicate code, is a really, really big deal once you start writing larger and more complicated programs, because your number one enemy is yourself. Your number one enemy is you're going to write code that seems easy while you're writing it, but if you don't try and simplify as you go in this way and in other ways, you're going to end up making something that's too complicated and it will overwhelm you. And this happens to all programmers, kind of no matter how good they are, no matter how smart they are. So part of being an excellent programmer is controlling the complexity by constantly simplifying in this kind of way. All right, so let's look at this one. So this is another one that's going to be nice to look in the debugger. So I've dropped the code here inside problem 4C. I'm going to click this line to add a breakpoint, and now I'm going to debug. And when I debug, now I'm paused on this line. I'm going to step one step. So it's showing me the current value of my array. So here I've just created my array. I haven't run this line yet. And as you can see, the array is full of zeros. Now if I take one step, I've run this line of code, and you see I've put 30 inside location 0. And as I step, now I've put in 40, and 50, and 60 and 70 and so on. And you can see the values changing up here also. So that's expected. So really what this code does is it creates a new array and fills it with those values. Okay, we could imagine this array being much longer, and if it were much longer, we wouldn't want to have one line of code to put in each value, because that's really wasteful. Instead, we should use a loop to make it a lot shorter. So let's see what that might look like. I know a loop will repeat a statement a certain number of times. This is what's repeating over and over and over again, but with small changes. So I'm going to add a loop. So I equals 0, I less than, how many times am I looping? It looks like 9 times total. So I is less than 9, I plus plus. All right, and so then what am I repeating inside my loop? I'm repeating something like this, only this number's changing and this number's changing. So this number, I need, if we look at what I used to have, this number needs to be 0 and then 1, 2, 3, 4. So it needs to start at 0 and count up by ones. That's exactly what I is doing. So I'll just make this one I so that I assign first to 0 and then to 1 and so on. Here we've got a similar situation to one of the last exercises. So something you could do that's it's not bad, but it's not great, is I could say value equals 30, and then I could assign value here, and then I could say value equals value plus 10. So now if I run the code, you can sort of see what's going to happen. Oh, did I not run it? Debug. All right, so now I'm stepping, so value's 30. So here we see on this line we've got our empty array 0 and 30. So we assign the 30. Now value goes up by 10. So now you can see value is 40, and it's changed from its original 30. And then here value is now 40, I is 1, so 40 gets assigned to location 1, and so on. So that's working. The reason I said that's not my favorite is we don't really need to introduce this value variable, because the value that we're assigning is related to the location that we're at. So we want to start at 30, and then each time I goes up by 1, we want the value to go up by 10. So in other words, we want 10 times however many i's there are. So this expression is a shorter way of calculating the same thing. I guess let's look at it again, just to prove that it's working. All right, so we're stepping. So you see 30, 40, 50, and so on. So that's doing what we want it to do. I want to show you a solution that is a common mistake. A lot of people get it wrong. So here's the same exercise. They create an array that's the right size, and they're looping j from 0 up to 8. And then I loops from 30 to 110, going up by 10 every time. So it's sort of like this is the value that we're assigning, and this is the location we're assigning it to. And I think this person made 2 loops because they thought, oh, well, there's 2 values. There's the location, and there's the number we're assigning to it. So we need one loop to change each of those things that needs to change. This is very, very important to understand how this is different than my solution. So if you have 2 loops like this that are inside each other, it means that for every single value of j, you loop through all of the values of I. I think this is going to be really obvious when I go through it with the debugger. So I've added the breakpoint. Let's run the debug, and you'll see what happens. So here I am. I take one step. I take one step. So j is 0, and now what's going to happen is I'm going to loop starting I at 30 all the way up to 110. So as I'm taking individual steps, so I've assigned 30 to location 0 here, but notice that I'm continuing just to loop in that inner loop. So I is going up, now it's at 70, and each time I assign that new value of I back into location 0 because j hasn't gone up yet. So I'm looping, 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 looping. Eventually I is at the end, and now we're back to the outer loop again. So watch on line 10 here. Watch as these values change as I'm clicking. So what's happening is for each of the j values, I'm assigning all of the I values one after another, and they all overwrite the old ones. So by the time I'm done, I'm going to have an array that's full of the value 110 from the beginning to the end. So that's really different than what I wanted, and the reason why is because of how this nested loop structure works. So that's a good thing to know about. So let's look at problem 6. The first question is, what does this display? I just ran it, and you see this is what it displays. Let's do it step by step, though, just to be sure that you understand, because it's really important that you get, for example, that this first line displays nothing at all. So I've put a breakpoint. We'll do our usual tracing with the debugger. So we see that I is 0, j is 0, and because they're both 0, this inner loop doesn't run at all the first time, because they both start at 0, and so it fails this loop condition. So now I'm just going to do a print line statement, so that's printed a line, and now I'm back up here. So I is 1, and now j initializes to 0, j is less than I, so we go ahead and print j is 0. Here we can look at it here in the debugger. So I'm just going to click one after the other, and you can look down in the console as it's displaying, and you can sort of think about what's happening. All right, cool. So let's look at what we really want to know about. So the first question says, could we make it count down from 5 instead of up from 0? So here's what I'm thinking. On each line, j is what gets displayed. So j is the thing that we want it to be counting down instead of up. So instead of starting j at 0 and going up to its maximum value, let's start it the other way around. So let's think, what is the largest thing that j could be inside this loop? I know that j is smaller than I, so the largest thing j is going to be is I minus 1, because that's the largest value you can get until j is equal to I, and this is no longer true. So I'm going to start j at I minus 1, its largest value. I'm going to make it count down by 1 every time by saying j minus minus, and I'm going to keep going as long as it's larger than or equal to 0. And so now if we run it, it is counting down, except for this 0, so maybe this is not what we wanted. No, actually I just reread the problem. I think this is what I wanted, because we're only counting down for all the numbers on each line. So since this line only has 0, it's not counting down yet. This line has a 1 and a 0, and it is counting down. So that makes sense. This is not the only solution. There's another one. You could have done this. So let's keep j going from 0 up to I minus 1. But then let's start at 5 minus I minus 1. Wait, does this make sense? So let's start it at... Let's think about this. Okay, so let's think about it this way. So as j goes up, we want the number that it displays to be counting down. What are we counting down from? Well, we're counting down from whatever the I value is. So on line 0, we're counting down from 0. On line 1, we're counting down from 1, and so on. So we want to start with the value I, but then we want to subtract whatever j is, because as j goes up, we're subtracting more and more, so this should be counting down by 1 every time. Let's run this. This is going to be slightly off. So this looks like it is counting down, but everything's 1 too large. We got 1, and then 2, 1, and then 3, 2, 1. So let's just subtract an additional 1. And now you can see we've got the same thing calculated in a slightly different way. I think this is a little bit less clear than the example that I did before, so I actually prefer the previous one, but this also works. All right, so the next problem says that we want to modify it again so that it displays a full cube like this. So what I'm noticing is a lot of this cube is the same as what we already have. So we've got 0, 1, 0, 2, or sorry, 0. Okay, so I actually guess it's not quite the same, is it? So what we already had was we're counting down from the line numbers. So counting down from 0, then from 1, then from 2. Here it looks like we're counting down from 1, then from 2, then from 3. 0, 1, 2, 3. Is that the same? Oh, it is. Okay, so never mind. 0, 1, 2, 3. So it's all the same. So all we really need to do is sort of pad this out with additional zeros. So let's think. We want to keep all the stuff that's working, and we just want to insert another bit that will display the thing we want. So the print line statement is the first time where it starts doing something different than what we want it to do. And I'll show you by putting in the stars here instead of just a straight print line. So if I run this now, these stars are where I want it to be displaying zeros for me. So what I'm going to do is I'm going to replace this with a statement that will display zeros. Well, obviously I can't just replace it with a normal print statement or even several print statements that display zeros, because the thing is, on the first line we want 5 zeros, then on the next line we want 4, and then 3, and then 2, and then 1. So it seems like the number of zeros we want to display depends on the line number. So I think we'll need a loop. I don't know what's going to be in the loop yet, but something. And we're going to display 0. So the question is, how many times do we want to loop? And we want it to loop 5, then 4, then 3, then 2, then 1. So one thing we could do is up here we could create like number of zeros starts at 5, and then here we could say j equals 0, j is less than num zeros, j plus plus, and then here num zeros minus minus. So now when we run it, number of zeros is 5. This will loop 5 times to display 5 zeros. Then when it's done, number of zeros will be 4. So the next time through the loop, this will only loop 4 times, and then 3, and then 2, and then 1. Let's look and see what that looks like, actually. Okay. So a couple of things. I did a print line here, so every single time it hits 0 in this loop, it's displaying on its own line. So let's make it print. And now let's look at it a second time. Okay. So now it looks like it's doing something like what we want, except we need it to be, I took out the print line, so let's put it back in, because I actually do want it to go to the next line only after it's done this chunk, which does the countdown, and this chunk, which does the remaining zeros. Let's look at it another time. Okay, so this is getting closer. I see that I've put in spaces, and then these zeros don't have spaces, so let's put in a space there as well, just so that we can see everything spaced out in a nice way. Okay, so this looks sort of like what I want, but not quite, right? Because it looks like I've got this first row twice, and then 1, 2, 3, but really I want this to be 1, and this to be 2, and this to be 3. So let's think about how we could fix that. So I want to think, where specifically does it start doing the wrong thing? So the J's are wrong, right? Because what I'm printing here is always kind of one smaller than it should be. So this should be 1, and this should be 2, and this should be 3. So if I think about where is j coming from, j gets initialized here as the line number minus 1. Because remember, I is the line number, and so j gets initialized to 1 less than that. So right now we say on line 0, j initializes to -1, so we skip it entirely, fill the row with zeros, and keep going. When I equals 1, we initialize j to 0, so we're counting from 0. So that is what's going wrong. So what if I start j out not at the line number -1? You know what? This might be easier if I rename this. So let's rename I to be. So let's rename I to be. Oops. Line number. All right. So now maybe this is more clear. Let's rename this one to be. Oops. Let's call this display number. All right, so we've got line number going from 0 to 4. Display number starts at your line number and counts down. So on line 0, display number starts at 0. On line 1, display num starts at 1 and counts down. So maybe this makes more sense. Let's try this now. Great, and I think that's what we want. Do we have one too many zeros? 1, 2, 3, 4, 5, 6. Yeah, we do have one too many zeros. So, oh right, so instead of 5 zeros, we want 4 zeros to start with because there's already going to be a single zero that displays. All right, so one more try. Great, so that makes sense. Let me show you a much cleaner way that you could have come to the same answer. Let's say that we hadn't done any previous exercises. I just say write some code that will use some loops to display this. Well, whenever you're programming, you want to create your own building blocks that will help you. So rather than sitting and thinking about how I want to loop, it looks like there's sort of a couple of pieces happening here. It looks like I want to loop 5 times. Oops. And then what I want to do is I want to count down from a certain number, and then I want to display a certain number of zeros. So let's imagine I had some helper methods. Let's say I have count down from, and then I can give it a number. So if I said count down from 1, it would display 1, 0. If I said count down from 3, it would do 3, 2, 1, 0. So let's imagine I had that method. And then display n zeros. And so display n zeros, I give it a number, and if it's 3, it'll display 3 zeros, and if it's 5, it will display 5 zeros. So let's pretend I had those methods. Now it's going to be pretty easy for me to write this code. So I know I want to start by counting down from what? So here I'm counting down from 0, then from 1, then from 2, then from 3. So here I'm just going to count down from I, because I starts at 0 and goes up by 1 every time. So this by itself should display the first part of what I want. So let's assume that's working. So if I've just counted down from 0, now I want 4 zeros. So I'd want this to be 4. But then the next line, I would be counting down from 1, so then I'd only want 3 zeros. So in other words, it's like I want 4 minus I. When I is 0, this is going to display 4 zeros. When I is 1, it will do 4 minus 1 is 3 zeros. When I is 2, it'll be 4 minus 2 is 2 zeros, and so on. All right, so that seems like I've decomposed it in a nice way. So now all I have to do is write these two methods. So here I am creating the count down from, and this we already know how to do. So let's see, for I equals 0, or let's say I equals n, I is greater than or equal to 0, I minus minus, and then system.print I. So I'm starting at n, I'm counting to 0, going down by 1 every time, and I'm just printing I. I guess let's put in a space. So I don't even have to think about, the nice part about decomposing it like this is a much simpler problem than the original one. But if I solve this one, I can use it to solve my original problem. So it's like breaking your big problem down into pieces. So let's do display n zeros. So if I'm displaying n zeros, similarly, I just want to loop n times and system.out.print 0 and a space. All right, great. So here I've got 3 methods, and in a sense this might feel more complex, but each of the methods does exactly one simple thing, and it made it much easier to think about this original problem. Let's just run it and make sure it does what it's supposed to do. I forgot the print line. Cool. All right. One more time. Great, that's what it's supposed to do. And now if I wanted to, for example, I could take an input here called size. So in our example, the size was 5. That's going to be size. This is going to be size. And now when I run problem 6, I could immediately do a size of 10. And when I run it, now it does the same thing. Did I mess it up? All right, well, I'm off by 1. But anyway, you can see how you could go back and fix this. It's nice because it's very generalizable. It was like very obvious what you would do to make the whole thing larger. All right, last one. Let's do problem 7. So in problem 7, you're supposed to display sort of a triangle of star characters. And in the hint, I'm saying use a for loop to count down from the user's number. Inside the for loop, make another for loop which will display that many star characters. So in other words, let's see, this is 1, 2, 3, 4, 5, 6. So it's like I'm displaying 6 stars, then 5, then 4, then 3, then 2. So let's go ahead and do this. I guess we need to take an input number. So I'm going to count down from the user's number. So int I equals n, I is greater than or equal to 0, I minus minus. And then what I wish I could say in here is I wish I could say something like display n stars, and I just give it my number. Because if this was a command that just displayed that many stars, if my number starts out at 6, then it would say display n stars, 6, and it would display that line. Then the next time through the loop, I would be 5, and it would say display n stars, and this would be 5, and it would display 5 stars. So this would just like literally do what we want if only this method existed. So let's write it. So here I'll have a loop, I is less than n, I plus plus. So I just want to loop n times and display that many stars. So system.out.print, there's a star and a space. And then at the very end, I think I just want to, I think I just want to do a new line there. All right, so this method is going to print, however many stars there are. And now I've got that in a loop. And let's see if it does what it's supposed to do with 6. All right, I'm going to delete this comment, delete that comment. So here I'm giving it an input of 6 that copies here, and we'll watch it go. All right, and it looks like that's worked for 6. Let's make it 10, see if it works for 10. Great, and that's worked for 10. So this idea where you're going to take a problem and you're going to figure out how to break it into a smaller problem, like the original problem is display this pattern. The smaller problem is, can you just display a certain number of stars on a line? So by solving the smaller, easier problem, it made it easier for me to solve the larger problem. And that is a huge theme in algorithmic thinking. It's how to decompose your big problems into small problems and then solve them individually. It's how great generals conquer nations. It's how programmers write excellent programs. All right, I think that's it. I hope this was helpful. If you have any other questions, please email me, and I'll see you guys on the next set.